Hey guys, Thoufiq here. In this video, let's try to solve a complex SQL query. Now this is an SQL interview query which was shared to me by one of my subscribers. Now all the data sets, the SQL query and the scripts that I'll be writing in this video, I will be sharing it in my Discord channel as well as in my blog, so you can download it for free. Okay. Now one more thing is I will be solving this query using PostgreSQL database and the PG admin tool. But let's say you're using some other RDBMS, then you can probably follow the same approach and the same query to solve this problem. But let's say if you're struggling to solve it in any other RDBMS, you can let me know in the comments below and I can try to help. Okay. Now without wasting any more time, let's straight away get into solving this particular problem. Okay, so the problem statement just tells that we need to write an SQL query to find all the family members, okay, as mentioned here. And they have given us the input data as shown here, and they have told us what the expected output is, okay. Now just by looking at this, we can see that we basically have input data which kind of looks like this. We need to write an SQL query which is going to transform this input table or input data into something that would return something like this. Okay, now in order to better understand this, the question is we need to find all the family members. So if you look at the input data here, we basically have three different columns. We have person ID, we have relative ID 1 and relative ID 2. What this means is this column person ID basically mentions all the different people that is present in the database. Okay, and for each of this person, if they have any relatives, their relative information is either present in this column, that is relative ID 1, or it might be present in the next column, that is relative ID 2. Okay, what we need to do is we need to scan through all the records of this table and we need to find people who belong to the same family. Okay, and all the people who belong to the same family, we need to group them together and then give them a unique family ID as shown here. Okay, so you can see here the very first record of our output. You can see we have 5 different family members mentioned here. So these are all the 5 different family members who are related to each other, and since they are all part of the same family, we need to group them together into a single column, into a single row, and then give them a unique family ID. And the same thing we need to do for every other person who is present in this input table. Now before I can start writing SQL query, let's first scan through this input table. Let's see how the data is mentioned, how we can come up with a logic which would transform the data from something like this into something that would look something like this. Right? So let's first spend some time to understand the data before writing the query. Now if you see the very first record in my input table, you can see I have the person ID ATR1 and he has no relative 1 and no relative 2. Okay, but let's say if I go to the second record here I have the person as ATR2 and he has a relative 1 by the name ATR1. Okay, so what this means is ATR2 is related to ATR1. Okay, so if I go to the third record, you can see that ATR3 is related to ATR2. Okay, so what this means is ATR3 is related to ATR2, and from previous record we found ATR2 is related to ATR1. So we can conclude that ATR1, 2 and 3 are all related. Right? Similarly, if I go to the fourth record, ATR4 here is related to ATR3, okay, and similarly the fifth record ATR5 is related to ATR4, as you can see here. So what this means is ATR1, 2, 3, 4 and 5 are all related, so meaning they belong to the same family. Hence we need to group all of those values together and give them a unique family ID as mentioned here. So this is basically we have grouped together one particular family, right? Similarly, we need to do for all the remaining families that is present in the input table. Now, if I proceed to the next record, that is BTR, you can see here I have BTR 1, 2, 3, 4 and 5. There are 5 records here and all their relatives are mentioned here, right, in the relative ID 2 column. So the relative can either be present in the first column here, relative ID 1, or they might be present in the relative ID. So if we need to find a relative for a person, we need to look at both these columns. Okay, so I think this is pretty straightforward here for BTR and ATR. And similarly, when I come to CTR, you can see that CTR has no relative 1, but he is related to CTR3, which is present in this column relative ID 3, right? And similarly, CTR2 is related to CTR1. So from this, what we can conclude is CTR1 is related to CTR2 and CTR3 is also related to CTR1. So CTR1, 2 and 3 are all related, and that is why you can see in the third family here, CTR1 to 3 belong to the same family, and we have given them an ID like F_3, right? Now I think until here it is pretty straightforward, nothing too complex. Now let's proceed to look at the other persons, because I think after this it kind of slightly might be a little more tricky. Okay, now you might assume that just based on the name we can conclude which family they belong to, because if the person ID is starting with ATR, then they belong to the ATR family. If it starts from BTR, they belong to the BTR family, and so on and so forth. But that is actually not the case. Okay, because as you can see here in this particular record here for DTR, you can see DTR1 is related to DTR3 and DTR1 is also related to ETR2. Okay, so here a DTR is related to ETR, so it's not like similar names will basically form the family. People with different names may also be part of the same family in this case, right? And that is why you can see DTR1, 3 and ETR2 are related, hence they are part of one family. And if you see here the family for DTR1, DTR3 and ETR2, that is basically what is mentioned here. Okay, similarly if I go to this record here, ETR1 is related to DTR2, so this means ETR1 is related to DTR2, and I have another family here, family 5, where I have mentioned DTR2 and ETR1. Okay, so this is a very important thing to note. Just based on their name, you cannot group the family together. You need to basically find for each person who is his or her relative, and based on that you need to form the family group, right? So that is the tricky part in this particular problem. Okay, now similarly there is one additional thing that you need to consider. Now there can be certain families who do not have any relatives, okay, or basically certain person who do not have any relative. For example, you can see I have three persons here, FTR1, FTR2 and FTR3. These are three individual persons, and you can see there is no relative for them mentioned here. And if I scan through this entire table under this column relative ID1 and relative ID2, I will not find any FTR. So this basically means that this FTR1, FTR2 and FTR3 are basically persons who do not have any relative. Hence, they will basically form families with just one member, that is themselves. And that is why you can see here F6, F7 and F8 family are basically three different families, but each of these family just has one member, that is themselves. Right? So it's not like because you saw three FTRs, you need to group them together and form a single family. That's not the way it should work. Each person, based on their relative, you need to find their family, right? And since FTR 1, 2 and 3 do not have any relatives, they kind of form the family on their own. Okay, so that's the important thing. Now finally, let's also scan through the last two type of families. You can see here I have GTR1, and GTR1 is a relative for these six persons, right? So I have GTR1, GTR2, GTR3, HTR1, HTR2 and HTR3. So all these six persons are related to GTR1. So in other words, we can tell that these six persons are related to one another, meaning that they form the same family. Hence you can see my family 9 here is basically including all these members, right? And finally my ITR, you can see that ITR2 is related to ITR3 and ITR2 is also related to ITR1. Hence ITR1, 2 and 3 are all part of the same family. Hence they form the family 10, right? So this is basically how you need to understand the data. Okay, I hope this is clear. I hope you understood how the relationship has been built and how from this input data, this expected output we need to derive. Right? So this is clear. Now we have understood just by looking at the data what we need to do. But how do we apply this logic using an SQL query? Now, if I had to do this using a procedure, it's pretty straightforward. I could have simply used a for loop and then use an if condition to just scan through all the records and then build relations. But using a SQL query, it's not that straightforward, because what we need to do is for every record, we need to scan through the entire table and find a relative. As soon as we find a relative, we cannot just treat those two to be part of the family, because those two might again be related to someone else, right? So using those two, again I need to scan through the entire table and see if they have any other relative, and I need to continue that until I scan through all the relatives in this table, right? And that is why I think one of the best way of solving this problem is by using recursion, right? We can use recursive SQL queries to solve this problem, and the reason why I think we can solve it using recursion is because for every person we need to scan through to find his relative. As soon as we find a relative, we again need to scan through some other relatives to see if they are related to anyone else, right? So this is where when you need to scan through a particular record and then taking that output, you need to again scan through an entire table again and do this iteratively multiple times. This is where you need to understand that recursive SQL queries might be a way to solve this problem, right? So we will try to solve this problem using recursive SQL query, but of course, like I always tell, SQL queries can be solved using several different ways. So if you have a better way or any other way of solving this particular problem, definitely let me know in the comments below. Or if you think your query is too big, you can also email me. My email ID will be in the video description. Okay. Now let's straight away get into solving this problem using recursive SQL queries. Okay, so as I told you, I will be using PostgreSQL database in order to solve this problem, and you can see I'm using the pgadmin tool. Now the very first thing is to basically create this input table in our database. So I have already done that. I have created a table by the name family members. Okay, as you can see, I have all the data that was given in the input data, and I have loaded it into this table. Okay, so I have already done that. Now I told you that we will be solving it using recursive SQL queries. Now let me first explain you the syntax of recursive SQL queries. Now let's say you are someone who does not know what a recursive SQL query is. Then I have made a separate video where I have explained in detail what recursive SQL queries are. Even if you are a beginner, I believe that video should help you. So you can definitely watch that video. I'll try to leave the link to that video somewhere in the video description. Okay. Now in order to write recursive SQL queries in PostgreSQL, we will be using the CT table, that is the with clause. So I'm just going to say with, and then I need to mention recursive, and then I need to give a name for my temp table. So I'm just going to say, let's say related family members, okay, something like this, and I need to have my as clause, and then below here I need to write my query. Now as part of this query there will be two different sections. So the first thing is we need to come up with a base query, and then we need to have a union clause, and then finally we need to write the recursive query. Okay, so this is basically the syntax, and finally we write our main query that will be select star from basically our recursive temp table. Right? So this kind of is the syntax of how we are supposed to write a recursive SQL queries. Now how the execution will happen is, when you execute this query, first SQL will come to know that this is a recursive SQL query. So initially it will only run the base query. Okay, because it's a recursive SQL query, this query will get executed multiple times iteratively, right? So in the very first iteration, only the base query will get executed, and whatever the output is written from the base query will be passed as an input for the second iteration. So when the second iteration happens, only the recursive part of that SQL query will get executed. Okay, so the base query only will get executed the very first iteration. After that the base query will not get executed. Okay, after that only this part will get executed until all the conditions are met. Okay, or until a termination condition is met, right? Okay, so in order to solve this problem, the very first thing that we will need to do is we'll need to come up with something called as a base query. Okay, now base query is something that gets executed only in the very first iteration of recursive SQL query. So it kind of becomes like the input for the recursive SQL query during the second iteration. Okay, so how do we come up with the base query? What is that logic that I need to follow in order to scan through all the records of that input table so that I can find all the relatives? Now one way of doing that is, what I can do is I can consider all the relatives that are present in both these columns. So you can see that for each of the persons mentioned in this table, the relatives can either be present here or they can be present here. Okay, and I know that if a person has relatives, only then in that group there might be more than one person. If a person does not have any relatives, then in their family group they will be the only person, right? Now this one we'll try to build separately, but let's try to first find all the relatives for each person. So what I'm going to do is, in my base query, I will consider all the relatives. Okay, so what I can do is I can just take all the data from this column, then do a union with all the data from this particular column. Okay, so that's going to be my base query. Now from there, what I'm going to do is I'll consider this my base query, and then for each of these relatives that I have found from my base query, I'm going to scan through all the records from my main table, that is my base table, okay, or my input table. So, and how I'm going to basically scan or match is using the relative ID 1 and relative ID 2 column, okay, and wherever there is a match, so basically the match will happen either based on relative 1 or relative 2. As soon as there is a match, I will see which person this relative belongs to, and I'm going to assign a group for each of this relative, and I'm going to create the group using the first 3 characters of this person ID. Okay, now this is a logic I'm going to build, and this is basically going to tell us each relative belongs to which person group. Okay, so I'm not going to find the person to which he is related to, I'm going to find the group to which he is related to. Okay, and based on that we will continue from there. Okay, so I'm going to start writing the query. I hope you will understand it along the way. Okay, even if you did not understand it now, along the way you will understand it. So just hold on. Now I told you my base query is the union of this and this. Of course I can do that union here itself, but it might be a little confusing because then we have another union here, so it might be a little not that clean. So in order to keep the query clean, what I'm going to do is I'm going to create my base query here. So I'm just going to say base query as, and here I'm just going to say select relative ID 1 as, I'll call them like, let's say relatives from my family members table. Okay, and what I want to do is when I'm fetching this, I don't want to fetch all these null values. As you can see, there are a lot of null values, so I'll just put a filter condition telling that where relative ID1 is not null. Okay, so that's one thing, and I'm just going to move this to the next line here, and I'll do the same thing for the next column. So this is all the relatives I have taken from relative ID1 column. I'll do a union here, and I'm going to put the next column here, that is relative ID2. Okay, and here again I'll say relative ID2 is not null. Okay, now this is fine. So what I have done is, if I execute this, this basically is going to fetch me all the relatives. Okay, as you can see here, now this data is not sorted in proper order, so I'm just going to do an order by here just to show you the data more clearly. Now if I run this, you can see ATR 1 2 3 4, BTR 1 2 3 4, and so on and so forth. So all the relatives have come here, which is my base query. Now one additional thing that I want to do here is, for every relative that I have fetched here, I also want to find which person they are related to, and the person to which they are related to, I'm going to create a group for that. Okay, so what I mean by that is, now you can see that I have ATR 1, 2, 3 and 4. So that is basically these 4 records. Now ATR 1 is related to ATR 2, ATR 2 is related to ATR 3, ATR 3 is related to ATR 4, and so on and so forth. So what I'm going to do is, I have already fetched the relative ID 1, that basically will be my ATR 1. Along with that, I'm also going to create a group. So my group is basically, I'm going to say the very first 3 characters from my person ID column for each of this relative. Okay, so with this what happens is, the group here will be ATR. So for all these 4 relatives, they will belong to the same group, that is ATR. Okay, similarly for all of these 4 relatives, that is BTR, they will belong to the same group, that is BTR. Okay, and so on and so forth. Okay, once I write that, you will better understand why I'm doing that. Now I'm just going to do that. I'll say substring of, and I need to find the person ID, and I'll just tell 1 2 3. Okay, so that is from the first character till the third character, and I'm going to name it like, let's say, fam group. Okay, so I'm just creating a group for each relative. So as soon as I extract a relative from my input table, for each relative I'll see which person they're related to. Based on the person they're related to, I'll fetch the very first 3 characters from their name, and that is basically going to be the group that I'm going to assign to. Okay, now I need this for my future processing. You will understand when I proceed. Okay, and what I'm going to do is, I'm going to create this same column here. Okay, so now if I just execute this query, you can see here ATR 1 2 3 4 belongs to the ATR group. Okay, so it's not like based on their name I have created a group. So it might look something similar to that here, but let's say if I proceed, so ATR BTR all looks like that. Okay, that basically depending on their name I have assigned them to a group. But let's say if I go to DTR, okay, so let's say I go here, so you can see this DTR2 is he belongs to the family group ETR. Why? Because you can see here DTR2 is this one, he's the person to which he is related to is this one, that is ETR1. The group that I have created for him or her is ETR, right? So that is how it is. So it's not that just based on their name I have created a group. Based on each relative to the person to whom they are related, based on that related person I have created the group. Okay, so this is what I have built. This is basically going to be my base query. Okay, now what I'm going to do is, I have my base query here, and I'm going to just query the data from my base query. So I'm just going to say select star from this entire table here. So this part is done. Now we need to come up with the recursive part of the query. So in the recursive part of the query, of course, we need to use our recursive temp table, that is this one. So only then it kind of becomes the recursive query, right? So this is one thing that I will use. I'll give an alias for this like R, and I need to do a join with my input table. That is basically my input data. Why? So from this related fam members recursive query or this table here, what I will get is, I'll basically get the output what is written from this base query. Right now, for every relative that is written from here, I want to scan through all the data from my input table. Okay, and I am going to do a join based on the relative ID1 and relative ID2. Okay, now you'll understand this when I'm writing the query. So I have this base query data returned into my recursive temp table. I have put it here, and I'm going to join this table with my main table, that is my input table. So I'm just going to copy it from here. Maybe I'll remove this and I'll put it here, and I'm going to call it like fam, and I'm going to do a join. So how do I join? Now at one side I have all this input, right? This is basically everything. So I'll just copy this, okay, and maybe I will just put it here, okay, just for understanding, and I'm going to call it like relatives. Okay, so these are all my relatives as you can see here, and this is basically I think around 16 or 17 records, which is basically returned from my base query here. Okay, so at one side, or basically on the left hand side of my join, I have these 16 or 17 relatives, and on the right hand side I will basically have this entire input table, right? What I want to do is I want to find these relatives in my input table. So how I'm going to do that find? I'll just try to match them either with my relative ID 1 column or with my relative ID 2 column. Okay, so when I find a match, I'm going to fetch their person ID from the left side. Okay, or basically from that for that corresponding record. Okay, so let's try to do that. So I'm going to do a join telling that fam dot relative underscore ID1 is equal to r dot relatives, right? Or, so this will be an or here because the relative can either be in relative ID 1 column or he might be in the relative ID 2 column. So I'm just going to copy the same thing and put it here, and this will be relative ID 2. Okay, and maybe I'll just move this to the next, okay, not this, maybe I'll just move this entire thing to the next line just so that it becomes clear. Okay, so in the recursive part of the query, I have joined my base query, result from my base query, and I have joined my input table based on basically joining based on the relative ID column. Okay, now from here what I need to fetch is I need to fetch family. So when I do a join, so this ATR1 will get matched with this particular record here, and I want to fetch this person, that is ATR2, right? So I'll just tell fam dot person ID. Okay, and I'm just going to say the group, right? I need the family group. Now the family group I have already got from my base query, that is here, this family group. So I'm just going to use that. So I'm just going to say r dot fam group. Okay, now I think that's all. I hope you kind of get some understanding from this. Now what I'm going to do is I'm just going to run this query and let's see what output I get. So let's say if I'm getting something, now it looks like I am getting some output, or basically I'm getting some data. So you can see that ATR 1, 2, 3, 4 is related to ATR. Where is ATR 5? I think ATR 5 is here. Okay, so the data is not sorted properly. So let me just do a sorting here. So order by, I'll say 1, and now I'll run this. And now you can see I have ATR 1, 2, 3 and 4 belongs to the same family group, that is ATR. Okay, and ATR 5 as well. And then BTR 1, 2, 3, 4, 5 belongs to the same family group BTR. Okay, CTR 1, 2, 3 belongs to the family group CTR. Okay, so I have basically grouped them together. And then comes this DTR. Now you can see DTR 1 is belonging to the family group DTR. DTR 2 is belonging to the family group ETR. DTR 3 is belonging to DTR. ETR 1 is ETR. ETR 2 is DTR. Okay, now this, it might be a little confusing to understand, but just from here I can see that DTR1, DTR3, okay, so if I just select this, DTR1, DTR3 and ETR2 belongs to the same family group DTR, okay, and that is exactly what I want, DTR1, DTR3 and ETR2, right? And then you can see that I have DTR2 and ETR1 which belongs to the ETR family group, okay, so DTR2 and ETR1. So this is how basically I have grouped all the relatives together into their correct family groups. Okay, now this is how that query has worked. Now I hope this is clear. I'll try to explain this query again at the end. Let's try to proceed from here. Okay, now this is fine, but I think this data may not be very clear for you to understand. To make it more clear, or to basically transform this data into how we want it, because for each family group, we need to group the data together in a single column, comma separated values, right? Now, whenever in PostgreSQL, we have this kind of a requirement, we can use a function called as string underscore aggregate. Now, I think this function is also supported in SQL Server, and I think in MySQL, we have, I think, concat group or something like that. So generally, every RDBMS would have some function like that. In PostgreSQL, we can use string ag. Okay, so what I'm just going to do is, I'm just going to say, okay, so I'll say string underscore aggregate, and here I just need to pass my relatives, I think, yes, and I'll say the separator should be a comma. Okay, and so let me execute this. Now you can see that all the values from that particular relatives column in the 33 records have been grouped together into a single column, single record. Now what I want is, I don't want to group all the family members together, right? Each family member should have their own group. So what I'm going to do is, I'm going to do a group grouping of data here based on the family group. So I'll say fam group by family group, okay. And let's say now if I run this, now you can see that I'm getting just 8 family groups, okay. So I hope this is clear. You can see that in my first group I have ATR 1, 2, 3, 4, 5. Then I have my second family group, third family group, fourth family group, fifth family group, sixth, seventh and eighth family group. Now there are a couple of things to note. The very first thing is I think these are not sorted in the proper order. You can see CTR1, CTR3 and CTR2. So they are not in proper order. Now if I want to do it in a proper order, I can just mention here something like order by relatives. This is just going to, when it's going to group the data together, it's going to order in a particular way. Now if I run this, now you can see I have CTR1, 2 and 3 and DTR1, 3 and DTR2. Now this is fine. The other thing is you can see here these two group that is created, basically they are the same, okay. So GTR123, HTR123, they are repeated twice. The reason why they are repeated twice is, if I look at my input table here, you can see this GTR is related to GTR family and GTR is again related to HTR family. So it's kind of, once it will match with GTR and the second time it's going to match with HTR, and that is why I get two different families. But basically these are the same families having the same family members. So what I can do is, I can basically consider them to be the same family, okay. So for that, what I'll do is I'll just use a distinct clause here, and now I'll run this. Okay, I'm getting some error. Now let me run this, and now you can see that from that 2 I'm only getting one family, okay, and this is exactly what I wanted, okay. So I hope this is clear and this is not too confusing. Now before I proceed to finally give a group ID for this, and then before I come up with a logic for this, I want to explain what I have done so far once again so I can make it more clear for you guys, okay. Okay, so going back to the query, what I have basically done is, let me just minimize this and show you the entire query here. So my intention was that I'm going to take all the relatives together as a temp table, okay. Then for each of those relatives, I will scan through my entire input table, okay. When I'm scanning, so when I took this, all the relatives, I also created a group to which they belong to, okay. So every relative should be related to some person, right? So what I did was, instead of mentioning to the person to which this relative is related to, I created a group for each person that they were related to, okay. So this relative ATR1, I created a group for him to which he was related. And how I know to whom he is related? Basically it is the person ID, right? Because all of these relatives that is mentioned here, they are related to this particular person, right? So from this particular person, I created a group by taking the first 3 characters of their ID or their name, right? And in that case, what happened was, all of these different persons basically got tagged to the same family group because they all belong to this kind of similar family, right? And the same thing happened for every record, okay. So in this case, ETR was related to DTR1, so the group that I created was DTR. Same way for DTR3 was again related to DTR1, the group that I created was again DTR, okay. So this was my base query that I built, and that was kind of built here, okay. So my relatives were either present in this column or in this column. So I first wrote the first query where I took all the relative ID 1, then tagged them to the appropriate group using the corresponding person ID, and I took all this relative 1 here, and then I did a union with all the relatives 2, all the relatives from the second column, right? So this kind of entire thing became my base query, okay. From here what I did was, in my recursive part of the query, I needed to basically fetch all the data from my base query. That's the very first thing. And in the second part, that is basically the recursive part of this query, I did, of course, I need to use the recursive, basically the recursive temp table name. That is what I have used here. Now this basically will have all the data that from the previous iteration of that query, okay. Because it's a recursive SQL query, it gets executed iteratively multiple times. In the first iteration, only the base query gets executed. In the second iteration, whatever output was written from the base query will be the input for the recursive query. So in the first iteration, this part will not even get executed, so that's fine. But in the second iteration, whatever was returned from the first iteration will be holded or will be present in this particular table, okay. So this, in this particular case, in our case, that would basically have these relatives. And then I joined it with my main table, that is input table family members, and I joined it either using the relative ID 1 and relative ID 2 because my recursive query here or my base query returned all the relatives, and I was trying to match those relatives in my input table under these two columns. Okay, I did that here. Now from when I did that, I fetched to which person they were related to and I put it here. Okay, so I got the person ID here. Okay, now that's all what I have done. So I built a base query, then I did this recursive part of the query, and finally the output that I got was all the relatives and their group, right? But then from there what I took was I just used this function string aggregate and I grouped all the data together by grouping them based on each family group, because I could see that these four and I think a few more basically belong to the same group. So all the relatives who belong to the same group had the basically same family group, and I grouped all the data based on that family group, and then I did the aggregation here. Okay, so because of that you can see that the final data that I have got is something like this. So I have come up with the 7 families. These are the 7 families with all the members that they have in each of their families. Now there are 3 families missing. If you look at the expected output, I need to get 10 families, right? The 3 families that are missing are basically these 3 families because these did not have any relatives, because I built the entire logic here by taking the relatives, right? But if there were some family members or basically some persons who did not have any relatives, then they would not be returned from this query. That is why I need to write a separate logic for them. So what I'm going to do is, how do I identify who are those persons who do not have any relatives? Now, one thing is I can see that they do not have any relatives, right? So if I just put a condition like select all the person ID from this table where relative ID 1 is null and relative ID 2 is null, then I will get these three, right? But along with these 3, there are many other persons who also do not have relative ID 1 and relative ID 2. So I cannot just put that condition, right? Because a relative of a person can either be corresponding to their record or they might be present somewhere else in that table, right? So that is why what I'm going to do is I'm going to fetch all the data from this table where these 2 columns are null, plus they should not be present in any other place in this table, okay, under these 2 columns, right? So because they do not have any relatives, so they will not have any relatives anywhere in the table in these 2 columns, right? So I'm just going to put that condition. Now I'll just create another temp table to identify those basically persons who do not have any relatives. Okay, so what I'll just do is I'll just create, okay, not here, but I'll create it here, and I'm just going to give a name like, let's say, no relatives. Now I'm trying to find those persons who do not have any relatives. I'm going to give the temp table a name like no relatives. I am calling this temp table. They are not actually a temp table, but they are something similar to a temp table. They will exist only until the execution of this query. So do not confuse this to like the realistic temp table that we have in SQL. Okay, so I'm just, for easier understanding, I'm just calling them like temp table. Okay, so I'll write a query to fetch all the persons who do not have any relatives. So what I'm going to do is select from my family members table. Okay, I'll just call it like fam, and I need to put a condition telling that let's say relative ID 1 is null and relative ID 2 is null. So this is the very first thing, right? But along with that, I also need to do one additional check, that is their person ID. Okay, so their person ID corresponding to these records should not be present in this query, right? This is basically all the relatives that I have taken from that table. So these persons, if they don't have any relatives, they should not be present in this table, right? So that is what I'm going to say. So I'm going to say select relatives from this table. So this select relatives from my base query will return all the relatives. Of course, if any person does not have any relatives, they will not have any entry here. So that is what I'm checking. So I'm only fetching those persons who do not have any relatives. Hopefully this should return me that data. Okay, and here I'm just going to print that person ID. Okay, and I think that's all I need. Now I have taken all the relatives here. Now I need to add them into my main query. So how I'm going to do that is, here I'll put a union. Okay, and let's say I'll put a union here, and let's say I'm just going to go down and I'll say from this table. So select, so I'll just tell select person, or it just has one column, so I'll just use select star from no relatives, right? So previously you could see that I think we had 7 family members. Now after this change, hopefully there should be some additional data coming from here. Okay, hopefully the 3 families or 3 persons would not have any relatives. Now let me run this. And now you can see that I'm getting 10 groups. Okay, and these are the 3 new groups that are added, because these are the only 3 persons who do not have any relatives and who are not present in my relatives table, that is in my base query, right? And that is what I have fetched. I think now I have basically got all the data that I need, as you can see here. Okay, and I think the data also is sorted in proper order because I've used an order by 1. Now the last thing that I need to do is I basically need to create this family ID. So for that, what I'll do is, now I want to basically create the unique row number for each of these relatives, right? Or basically for each of these family groups. So what I need to first do is I need to put this entire thing into a subquery. Okay, so because I need this value that was returned from this string aggregate function. So I'll just give a name for that. Let's say relatives. Okay, what I'm going to do is, okay, maybe I'll just run it and show it to you once. Now you can see I just gave a name for whatever was returned here. And now what I'm going to do is, let me put this entire thing into a subquery. So I'll just move this to the right. I'll just say select from, and let's say I'll open the parenthesis here and I'll close the parenthesis here, give an alias for that, let's say X. And then here I'm going to derive all those columns that I need. Okay, so the first thing is I need the family ID. So I'm just going to say concat f underscore, and then here I need to find my unique number. So I'm just going to use the row number function, and let's say row number of this over, and I'll say order by relatives. Now I think it should work. Of course, I could have put this inside here itself, and instead of using these relatives, I could have used this entire string aggregate function here, but I think it would have become a little messy. So that's why I think to make it more clear, I just put entire thing into a subquery. Okay, and then here, let's say I'm going to call it like, let's say family ID, and in my next column is going to be relatives. Okay, so I think that's all. Let me run this. And now you can see I'm getting the expected output. So let me just move this to the right. You can see I have F1, F2 until F10. And you can see that I have ATR, BTR, CTR, DTR family, and ETR family, FTR family, and this GTR family and ITR family. So I have basically got all the family as per my output here. Okay, so this is basically how I have solved this query. I'm not sure how easily you understood this query because it was a little confusing for me to explain as well, but I hope you found the query to be interesting. All the scripts, data sets and the query, I will be sharing it with you in my blog. You can download it from there and you can try to solve it in a different way if you can. Okay, so all the best in solving this problem, and I hope you enjoyed it. If you like this kind of video, then let me know in the comments below. I can make more such videos. Thank you and see you soon in the next one. Bye.